So if there is a significant linear correlation between those two values, x and y, then using the line of best fit, in other words, using the regression equation, to predict the value of y is going to be a valid thing here. Versus if there is no significant linear correlation, then actually using the line of best fit would not necessarily give us a meaningful prediction. In that case, then you're better off using the mean of the y variables. In other words, y bar, using y bar. So with that, then that kind of tells you something, what you might expect the y variable to be independent of what x is. Because notice that here, because there's no correlation between x and y, we wouldn't expect y, our prediction for y, to depend on x at all. And so here we're just computing the mean of all the y's to make a prediction about what y would possibly be. So in this case, it seems logical that y would be somewhere around its mean. So let's try this out with this following example. Here we want to say, are fat and sodium content related in fast food? So looking at a bunch of different burgers, we look at the fat content and the sodium content in each. And here we want to use a 0.05 level of significance to determine whether there's a linear correlation. And if there is, then perhaps we can use that line of best fit to make a prediction about y. Otherwise, if there is no correlation, then we'll use the mean of all those y values to make our prediction. So let's state the null hypothesis and alternative hypothesis for this scenario. Again, because we're testing correlation, we're going to assume here for the null hypothesis that our population correlation coefficient is equal to 0, and alternatively it'll be not equal to 0. So after I've entered the data from the previous slide into an x and y column, I can compute the test statistic, or in this case the correlation coefficient, using the LinReg t-test. So here I get a correlation coefficient of 0.1990 if you guys run the LinReg t-test to get that. Once we have the correlation coefficient, we can compare that with the critical value. In this case, I'm going to avoid the p-value method and just look at the critical value. In this case, I think we had 5 data, and or no, I'm sorry, we had 7 data, and a significance level of 0.05. So we're going to use a critical value of 0.754. So clearly, in this case, the correlation coefficient that we computed is not going to be outside that region where we can reject the null hypothesis. So in this case, it's going to fall somewhere in the middle. In fact, it's going to land pretty close to 0, right? 0.1990 would be maybe somewhere around here. So because it's in this region in between here, we know we're going to have to fail to reject. So, and it's pretty close to 0, so that tells us that it's very possible here that there is no correlation. Yeah, so we're going to fail to reject. And so there's not enough evidence to warrant rejection of the claim that rho is equal to 0. So in this case here, it's possible there is no correlation. Or if there is one, it's a very weak correlation. So not strong enough in this case to really say for certain that there is a correlation. So with that, we can make a prediction. Instead of using the line of best fit, we'll use the mean of all the y values instead. So since we ran the linreg t-test with all our data, it also gives us the line of best fit. So we can use that in the case when there is a correlation. But if you recall, we just showed that there is no correlation. So is this line going to be helpful? And the answer is no, right? Because there's no correlation, which really tells us that the data does not fit the line very well. And so using the line of best fit to make a prediction here is not going to make a very good prediction. Okay, and so instead we'll use the mean of all the y values to make a prediction. So if I want to predict the sodium level of a burger, in this case it's 25 grams, but notice here, because there's no correlation, any value of x shouldn't be used to predict the value of y. And so any value of x, or in this case 25 grams or any amount of fat, would give me the same prediction because we're going to use the mean. To make a prediction. Right? Since we just kind of explained above why this line of best fit is not going to make a good prediction. Otherwise, if there was a correlation, then we would just plug that value of 25 in for x, and that would be our best prediction. But here, because there's no correlation, we're going to use the mean instead. So if I take the mean of all the y values, I get something around 1,138.57. So that tells me that roughly 1,139 milligrams of sodium is what we would expect in a burger with 25 grams of fat. Okay, but again here, regardless of how many grams of fat are in the burger, we're going to have the same prediction for the sodium level. So what they're describing below here are a couple of useful tools for us to help us visualize a scatter plot. So this kind of allows us now, and we can try it with the data that we have already in our lists for x and y from this previous example. But basically what it's going to do is it's going to give you a scatter plot of the data, and it's going to give the line of the best fit in the same picture. When we do this first step here, turning diagnostic on, what that does is that it actually gives us the correlation coefficient in the graph. So it allows us to view the correlation coefficient with the graph. Stat edit, enter the first variable in L1 and the second variable in L2. So that's just entering the data into a list, into our X and our Y list. The next step here, we're entering we're entering the line of best fit into one of our functions, so that allows us to graph the line of best fit along with our scatter plot. And actually, one thing that's sort of left out here is we want to make sure that our scatter plot is turned on. And so to make sure your scatter plot is turned on, you can go to second stat plot. It's right underneath the right above the y equals button. So if you look at the button that says y equals, right above it, it says stat plot. And there you want to make sure that you turn plot 1 on. You want to turn it on. So you'll enter and make sure you enter on, and make sure the X and the Y list both correspond to the X and the Y list that you entered here. Okay, so that way now when you graph that line of best fit, you will also see the scatter plot data on the same graph with it. So that helps you visualize how well that data fits with the line. And I would suggest that you maybe try it with the example that you just did here, and you'll probably notice that the data and the line of best fit really don't match up very well. And so that's why here we're not going to be using that line of best fit to make predictions.